In this video, we're going to talk about substitution reactions, specifically the reaction involving the creation of an alkyl halide. We're going to start with our general reaction scheme. So we'll start with an alkane as our reactant. So I'm going to draw methane here so that we can walk through this. So I'm going to draw CH4, and I'll do a structural diagram so we can label which hydrogen we're swapping out. We're going to add a halogen. So in this case, I'm going to add bromine, so Br2. So remember, all of our halogens are diatomic. We react this in the presence of light. The light provides a necessary initiation step, which I'll show in a little bit. What's going to happen here is we're going to take one of these hydrogens and we're going to swap it out with one of the bromines. So we're going to create an alkyl halide, in this case bromomethane. So our bromine will be there. Only one hydrogen is swapped out, and then we create hydrogen bromide, or a hydrogen halide, as a byproduct. So this product, our bromomethane, this is the organic product we create. HBr is the inorganic product. So I'm going to walk us through the general reaction mechanism. This is not curricular for Chem 30, but might help you understand what's going on. So if we have our bromine, we have Br, and I'm going to draw the actual electrons in that bond just for clarity. And we hit that bromine with some UV light, which I'm going to draw as a little squiggly arrow. Those electrons are going to leave that shared bond, and each one is going to go back to their original bromine. So now we have these unpaired electrons on bromine. These are highly reactive because electrons really prefer to be paired. They're most stable when paired. So these singlet electrons are now going to seek out opportunities to pair up. So we have our methane molecule, and I'm going to draw this bond with our two hydrogens. So what can happen here is one of our bromines can steal this hydrogen, and the hydrogen is going to take back its electron. So a carbon-hydrogen bond is almost nonpolar, so there's not going to be a really big difference in electronegativity there. So our electrons in that bond are going to split. So what we have now is we've formed our HBr, our byproduct, but we have this, what we call a free radical. So when we have an unpaired electron, it's called a free radical on our methane. And we still have the other bromine with its unpaired electron. So these two electrons can kind of meet up in the middle and form a new bond. So now we form our organic product, and we've terminated or stopped the free radicals. So one bromine is going to react in a couple different ways once it splits into its two atoms. We're going to go through an example now, and we're going to look at what would happen if multiple products can form in a reaction. So I'm going to draw a molecule here. So I have drawn 2-methylbutane. And if this is reacted with chlorine in the presence of light, we can form lots of different products because there's lots of different hydrogens to swap out. So on this 2-methylbutane, I'm just going to use some colors, and I'm going to put dots to represent the hydrogens. So our end carbon there has 3 hydrogens. The second carbon has 2. Our third carbon here with the methyl group has 1. And then both of these kind of methyl groups off of that carbon have 3. Now I've color-coded these carbons in such a way that all equivalent carbons are colored the same way. So if I swap out any of the yellow carbons, I'll get the same product, or any of the yellow hydrogens, I'll get the same product. Any of the blue, same product. The green, same product. Red, same product. So if I swap out one of the yellow hydrogens, my chlorine will go on the end of my molecule. So I'll still have my butane with my methyl. And I would have, and I'm going to just write this in yellow so it corresponds, 1 chloro, 3 methyl, butane. If I swap out one of the green hydrogens, I have my methyl butane, and I put a chlorine on number 2 there. And this is going to be 2 chloro, 3 methyl, so the chlorine gets preference in naming. 2 chloro, 3 methyl, butane. If I swap out that blue hydrogen, I now have a di-substituted number 2 carbon, so I would have 2 chloro. I'm going to run out of room, so this is going to be on 2 lines. 2 chloro, 2 methyl, butane. And lastly, if I swap out that red hydrogen, any of them, I have my butane with my methyl, and then a chlorine here, and I will have 1 chloro, 2 methyl, butane. And so as you're working through these, the more complex the structure of the alkane, the more products you can get. You won't have to predict what product is most likely or the various ratios. You just have to predict how many are possible.